Hello, grade 12s. We're starting a new section, exponential and logarithmic functions. This is still book 1, okay? And what I've done is I've just printed 2 slides per page. It just makes it a little bit easier. Okay, so moving on here, it says example 1, determine the equation of the exponential function passing through the point 3,8 if the equation is of the form y is equal to b to the x. They've gone on to say here that b must be greater than 0 and b can't be equal to 1. Okay, so we know that it's in this form y is equal to b to the x. Okay, and what I'm going to do is I'm going to substitute this point in here. Remember that this is our x value and our y value. So y becomes 8 equals b to the power of 3. I want to get the b on its own, so I take the cube root of that, take the cube root of this side, and we get 2 is equal to b. Okay, so therefore, this equation is y is equal to 2 to the x. As easy as that, guys. Then, going on to the next slide, example 2. Now what they're doing is they're talking about reflections. Okay, and now before I go into this example, I just want to show you some of the rules that we use for reflections. Okay, so the one thing is if we're reflecting about the y-axis. So reflection about the y-axis. Okay, so with this, what I do is I just draw a little picture. Doesn't have to be perfect, guys, just a little rough thing, and it'll help me figure out what's going on here. So if I've got, let's say, a point over here, and let's just say that this point is 2, 1, and we reflect this point about the axis, the y-axis. So that means because this is your y-axis over here, we're going to be flipping this point about the y-axis like that. So this point will come over here. Okay, and you can see if we flip it like that, what is going to change? Well, this is going to become minus 2, and that will still remain a 1. Okay, so the rule for flipping it about the y-axis is whatever our coordinate is, x, y, will now be mapped to. Let's have a look here. Here's our original point. So we're going from this to this. So our sign has changed. We've gone from 2 to minus 2. So that x is going to minus x. For the y, we're going from 1 to 1, so the y has not changed. That is our rule for reflection about the y-axis. Okay, so reflection about the y-axis, that is what happens. Then, if we have a look at a reflection about the x-axis, we can see what happens now. So again, I'm just going to use this little example that I have here, but it'll work for any point, guys. So if we take this point here, 2, 1, and now we reflect it about this axis here, the x-axis, you can see that if we flip it like that, this point will now come over here. And let's see what's happened. So you can see that the x value hasn't changed. It'll still be 2. But now what's happened to the y value? It's now gone from 1 to minus 1. Okay, so the rule for flipping about the x-axis, whatever our coordinate is, x, y, will now be mapped to. Here you can see that the x's haven't changed their sign, so it's still x, but the y has changed its sign. Okay, so that is the rule for the reflection about the x-axis. Okay. So that's going to help us answer these questions over here. So if we have a look at this, this is our original function here. F of x is equal to 3 to the x. Determine the equations which define the function h, which is the reflection of f in the y-axis. So if we have a look here for this rule for the reflection in the y-axis, what is changing? Our x is going to minus x. So this function here, h of x, will now be equal to This x here is now going to change to a minus x. So we get 3 to the minus x. Okay, and we can just maybe take this a little bit further, and we can just say that this is 1 over 3 to the power of x. Okay, just to make our exponent positive. Then if we look at this one, the function g, which is the reflection of f in the x-axis. So for this one, I'm going to do a little bit something different just to show you guys. I'm just going to say that this is y is equal to 3 to the x. That's our original one, okay? And you can see with the reflection in the x-axis, what changes is our y changes to a negative. So this y here will now change to a negative y equals 3 to the x. We never leave an equation like this, so I'm just going to divide through by the negative. And we get y is equal to minus 3 to the x. But they want it in the form g. So this is g of x is equal to minus 3 to the x. Okay, so just with the reflection in the x-axis, I like to do it like this because we still need to divide through by that negative. Then, question 3, the function p, which is the reflection of g, which is this one here, in the y-axis. Okay, so remember, reflection in the y-axis, x goes to minus x. So here we'll get p of x is equal to, that x there will now change to a minus x. So we still have the minus 3 minus x. Just to make our exponent positive, we get minus 1 over 3 to the power of x. Okay, guys. Then it goes on to say here, important, the function p could also have been obtained by reflecting h in the x-axis. So we could have reflected this in the x-axis. Okay, going on to some of the graphs now, guys. So it says here, sketch the following graphs on the same set of axes. And what I'm going to do is I'm just going to color code these things. So I'm going to make this one, I'll just make that a black dot. I'll make this one a red dot, a blue dot, and then a green dot. Okay, just so that when we come to draw it, I'm just going to highlight them. Okay, so for now, we're just going to use the table method, and all we do is we just substitute minus 1, 0, and 1 into here, and we get our output values. Likewise for this function, get our output values. Likewise for this one, output values, and then the same for that one. Okay, so what I'm going to do is I've already printed out the answer just to save some time. And what I'm going to do is just highlight these again for you guys. So that will still be the black dot, red dot, blue dot, and then the green dot. Okay, so there's your table values, which you guys can fill in. Now, to have a look at which graphs these are, this one here will be your red graph, or your red dot. Okay. This one here will be your blue. And then we've got the green one here. And then we've got the black dot graph over there. Okay, guys. And it's just as simple of putting your points in here, your coordinates, and then joining the dots to make your graph. Okay. Once you guys have got that down for me, then you can do exercise 3.2, number 1B, C, E, 2A, C, 3, 4, 5, 6, 7, and 8 for me. Thank you, guys.